Hi everyone, welcome to this tutorial on Elastic Net Regression. In this video, we will cover the basic of Elastic Net, explain its significance, and walk through how to implement it using Python and Scikit-Learn. By the end, you will understand how to use Elastic Net for linear regression, problem that benefit from regularization. Let's start. So before we start this, let's first understand what is Elastic Net. So Elastic Net is a powerful linear regression technique that combines the strength of two other regularization methods, Lasso and Rigid regression. So Lasso it stands for least absolute shrinkage and selection operator. Add an L1 penalty to the linear regression, promptly sparsity by shrinking some coefficient to zero. Rigid add L2 penalty which discourage large coefficient but don't force them to zero. Elastic NetBlend blend these two methods with a mixing parameter, giving us the flexibility to use both penalties simultaneously. So it's particularly useful when you have many features, some of which may be correlated. So Elastic Net is ideal when you have a large number of predictors or some predictors are highly correlated. So it can handle situation where Lasso might struggling due to multicollinearity, perform feature selection just like Lasso, prevent overfitting by adding regularization just like Rigid. So in short, Elastic Net works well when Lasso or Rigid on their own might not give the best result. Now let's jump into the code. So before we start, we need to make sure you have installed the necessary libraries. And first, let's impose the required libraries. Next, we'll create some synthetic data using make regression from Scikit-Learn. So this data set will simulate a regression problem with some random noise. So let me run this. Here X contains the feature matrix and Y is the target variable. Now we will split the data into training and testing sets to evaluate our model. So let me run this cell. So we'll use 80% of the data for training and 20% for testing. Now let's define and train our elastic net model. We'll specify two key parameters, the alpha and the L1 ratio. So alpha controls the strength of regularization. Higher value apply more regularization. And involved ratio control the mix between lasso L1 and rigid L2. A value of 1 is lasso and 0 is rigid. So we are using zero point 0.5 here. Next, we initialize the elastic net model. So let me run this. And next, we train the model. So we have set the alpha 1.0, L1 ratio 0.5, which we are giving equal weightage to lasso and rigid penalties. So once the model is trained, let's evaluate its performance on the test data. So the score method in the scikit-learn give us the R squared value, which tell us how well our model fits the data. The closer the R squared value to is to 1, the better the model performance. Now to visualize the effect of regularization, let's plot the true value versus the predicted value. So the scatter plot shows the how close the predicted value are to the true values. The red dashed line represents the perfect prediction. Now Elasticnet has two hyperparameters that we can tune to improve the model performance, the alpha and the L1 ratio. So we can use grid search CV to find the best combination. So here we are tuning the hyperparameters, and this will search over different values of alpha and L1 ratio using the five-fold cross validation to find the best combination. Let me run this, and after running the grid search, so let's check the best combination. So these are the best parameters for this particular problem. So ElasticNet is a robust regularization technique that combines the benefit of both lasso and rigid regression. By tuning its parameter, we can achieve a well regularized model that performs well even with a correlated features. Thank you for watching. If you found this Video helpful, make sure to like, subscribe, and comment. If you have any question or suggestion for the future tutorials, happy coding.